And bioaugmentation then is actually adding microbes to the area, microbes that are not indigenous. If you had an oil spill, for instance, and you wanted to clean up that oil spill, you might bring in microbes that are good at breaking down oil, add them to the oil spill and help them break it down.
Help it clean up
Yeah. Most probable number. Most probable number. Like I said, we'll talk about that in lab for those of you that haven't had it yet. Any questions about environmental microbiology, wastewater treatment, water treatment?
Do we have to know the 3 stages and what they are?
Absolutely.
So we can say that bioremediation, we're using bioremediation to clarify our water, right?
To treat our wastewater, certainly. The activated sludge tank is a type of bioremediation, biostimulation, in that we are putting oxygen into the water to help the bacterial activity. So yeah, I would classify that, qualify that as a biostimulation process. So let's turn our attention to food microbiology. If you think about it, practically all food harbors microbes, harbors bacteria. Kind of makes sense. Food is a pretty fertile environment, lots of nutrients and stuff to grow on. You think about how microbes get on food, though. There can be microbes in the soil, but a lot of times the microbes get transferred to the food through the handlers of the food, the harvesting of the food, packaging, storage, all of these can introduce microbes to the food. And then once the microbes are on the food, if the conditions are right, they can grow and they can cause changes to take place. Now, when we talk about changes that microbes do to food, there are really a couple of effects that can happen. Some of those changes actually are desirable. Changes that we like. We think of these in many cases as certain fermented foods. So milk to sour cream is a desirable changing of the food that is carried out by bacteria. Beer and wine and soy sauce are all changes that are carried out by this fermentation process that bacteria carry out. Desirable. However, when the change is undesirable, we call it spoilage. But here's the thing. We are really talking about the same process. It's a fermentative process that leads to either alcohol production or, in the cases of most of the foods that we're talking about, an acid production, a lactic acid production many times. So it really depends on the food and the individual's personal taste, if you will, what we consider desirable and what we would consider spoiled. In many cultures, something considered desirable might be considered spoiled to us. You know, how do you go about eating something that's spoiled? You can imagine the first time someone tried spoiled milk, you know, cottage cheese or something. out of necessity, I'm sure. Well, when we think about foods and bacteria growing on foods, we can realize that there are certain factors that are going to influence whether or not bacteria are able to grow on any particular food. Certain conditions are going to promote the activity of specific bacteria, but certain conditions will also inhibit the growth of microbes. We can have intrinsic factors. These are going to be factors then that are part of the food, and we can have extrinsic factors. Then that would be stuff that are outside the food itself, outside the food proper. Temperature and atmosphere, for example. If we look at intrinsic factors first, we are talking now about nutrient, moisture, pH. These are factors that are part of the food and allow for the microbe to grow. Intrinsic factors then are going to be things that are part of the environment. The temperature, the oxygen level, those are things that will also influence bacterial growth. Let's start with intrinsic factors and look at water availability. For an organism to grow on food, there has to be water available for the organism. Just because food is wet doesn't mean water is available for the organism. Foods that are going to be high in sugar can actually have a low water availability. You think about if we were to assign a value to water, pure water would say has a value of 1.0. When we look at most foods would then have a water availability that is close to about 0.98. But as foods become more salty or higher in sugar content, for instance, ham has a water content of 0.91. So not as much water available. Jams have a water content of about 0.85. Cake has a water content of about 0.7. Now think about what grows on these foods. Okay? Normal foods, leftovers and stuff that you might put in the refrigerator, probably have bacterial growth and fungal growth within a few days. Ham can sit in your refrigerator longer before you start to see growth of microbes and stuff. Jam can sit in your refrigerator for years. Right? How many of you probably got jam? Jars of jam, maybe 3 or 4 jars of jam that are opened, and you probably don't see any bacterial growth or any microbial growth because there's no water available. The jams are very moist, but the sugars have tied up all the water molecules. So there's no water available to the microbes to grow. Cakes, very dry foods, no water available. Breads, no water available. So you don't see bacteria grow. Now, as far as cakes and some things, fungi actually can grow at lower water availability levels. Usually around 0.8, you can see, still see fungal growth. Cakes probably not so much because they got sugar in there as well, so it's almost no water. But bread that has very little water in it, first thing that grows on bread is fungi. You know, look at the bagels that we had in class. Fungi grow on those as well. In addition to that, most bacteria are going to require a water availability that's somewhere around 9.0 or higher. So that's going to, the amount of water that's available to the microbe will dictate what type of microbe will be able to grow. So water availability is an intrinsic factor. pH, also an intrinsic factor. If you think about it, many bacteria are inhibited by lower pHs, by more acidic conditions. There are exceptions to this, of course. We saw that some lactic acid bacteria actually prefer a more acidic environment. We'll see later on in the semester Streptococcus mutans and some bacterial or oral bacteria prefer a more acidic environment. But generally, a more acidic environment is going to inhibit bacterial growth. But that then favors fungal growth. Because fungi can grow in more acidic environments. Again, think about the foods that you have at home and what you see growing on them first. Oranges, grapefruits, these are very acidic, citric acid foods, and the first type of microbe you see growing on them are going to be molds, fungi. And they can tolerate that acidic environment, whereas bacteria cannot. Nutrients. Nutrients are another intrinsic factor. Okay, so some microbes require specific sugars. If lactose is a required sugar, then you're only going to be able to grow where lactose is available. You may only be able to grow in milk. You're not going to be able to grow on an orange or on bread or something like that. Maybe a particular vitamin